Given question: for 4-stroke engine, power developed 25 kilowatt per cylinder at 2500 rpm. Specific fuel consumption 0.29 kilogram per kilowatt hour. Fuel with 30° API. Fuel injection pressure 150 bar with crank travel of 25 degree. Pressure in combustion chamber is 40 bar. Coefficient of velocity 0.875 and specific gravity is given by 141.5 divided by 131.5 plus degree API. Calculate the diameter of the fuel orifice. Let us understand given data. This is the 4-stroke engine and power developed 25 kilowatt per cylinder. We will use the notation as a capital P for the power developed. Speed is given 2500 rpm, that is the revolution per minute. So for speed we will use the notation capital N. Specific fuel consumption, that is SFC, is equal to 0.29 kilogram per kilowatt hour. Fuel with 30° API. So this is the term API used to calculate the specific gravity of the fuel. Fuel injection pressure. So we will use the notation. So this is the injection pressure. So I will use the notation PINJ. So it is 150 bar, but the standard unit is Newton per meter square. So how to convert this? So it is 150 into 10 raised to 5 Newton per meter square. Then crank travel. So it is also known as crank angle. So it is crank is travelled by through the angle theta, which is equal to 25 degrees. So we will use the notation theta. So theta is 25 degree. Cylinder pressure. So as here the injection pressure, cylinder pressure is also given. So it is also known as the combustion chamber pressure. So it is 40 bar. So I will use P cylinder, that is PCYL. This is the notation, and it is the standard unit Newton per meter square. So 40 into 10 raised to 5 Newton per meter square. Coefficient of velocity. So it is known as the coefficient of discharge, that is CD. So its notation is CD. So it is 0.875. And specific gravity. So how to calculate the specific gravity? Its a formula is given: 141.5 divided by 131.5 plus degree API, where the API in degrees is given, that is equal to 30 degrees. So we have to put the value 30 degree instead of API, and we have to calculate the specific gravity of the fuel. So from the specific gravity of the fuel, we can calculate the density of fuel. So density of fuel is known as rho F, and which is equal to specific gravity multiplied by 10 raised to 3. So this is the given data, and we have to calculate the fuel orifice diameter, that is D. So for that we have to first calculate the orifice area. And to calculate the orifice area, we will first calculate the different terms. Now from the given data, we will first calculate specific gravity of the fuel. It is equal to 0.876, and from that we can calculate the density of fuel, that is we have to multiply 10 raised to 3, that is 876. So this is the density of the fuel. Now duration of injection. So how to calculate the duration of the injection of fuel? So for that we will use the standard formula theta divided by 360 multiplied by n by 60. Now if we observe, speed n is given in rpm, revolution per minute. So when we divide it by 60, we will get this value in rps, that is revolution per second. So when we put the value, so theta is 25 degree, 360, n is 2500 divided by 60. So we will get the answer, this duration in second, because we have used here revolution per second. So 1.66 into 10 raised to minus 3 second is the answer. Now we will find out the velocity of the injection. So this is the duration of injection and velocity of the injection. So velocity of injection formula is CD, that is the coefficient of velocity, under root of 2 injection pressure minus cylinder pressure divided by density of the fuel, that is rho f. So I have used here the notations. So we will put the value. So CD is 0.875. Then we have to take this pressure in Newton per meter square. So we will take 10 raised to 5 as a common term, and rho f, that is 876, that is the density of the fuel. So answer is 138.66 and the standard unit is meter per second. Now we will calculate volume of fuel injected per cycle. So for the volume of fuel we will use the notation capital Q. So its a formula is specific fuel consumption multiplied by power output divided by capital N by 2 multiplied by rho f, that is the density of fuel. Now why this term capital N by 2? So because of 4-stroke engine we have to take here the N by 2, and when there is 2-stroke engine we have to simply consider only N. So this is the difference in between the formula for the 2-stroke engine and 4-stroke engine. Now specific fuel consumption. So here it is given in kilogram per kilowatt hour. Now we will first balance the units. So I will write the unit kilogram per kilowatt hour. Now power developed. So it is given in kilowatt per cylinder. So I will write here multiplied by kilowatt per cylinder. Capital N by 2. So here N is given in RPM, that is the speed. So it is in denominator. So simply we will take here RPM, and density of fuel. So density of fuel is always in kilogram per meter cube. So it is in denominator. So we will take meter cube per kilogram. Now if we observe here, this kilowatt is getting cancelled, and this kilogram is also getting cancelled. Now here is revolution per minute, and here the unit is hour, that is this is two different units. So we have to change this unit. So how to change? We have to convert this hour in terms of minute, and here revolution per minute we will take as it is. So how to convert this? So it is in denominator, and in 1 hour there are 60 minutes. So we have to here take 60, or we have to simply take 60. So SFC is equal to 0.29 divided by 60, because per kilowatt hour. So here we will take 60 multiplied by power output 25. So it is 25 kilowatt per cylinder. Then N by 2, 2500 by 2 revolution per minute, and density 876 meter cube per kilogram. Now if we observe, this is the time, that is hour or minute, and this is RPM. So what is the answer? 1.1 into 10 raised to minus 7 meter cube per cylinder, or we will say we can also say meter cube per cycle. So this is the volume of fuel injected. Now we have other formula for the volume of fuel injected. So Q is equal to area of all orifices multiplied by injection velocity multiplied by the time of the injection. So we will put the values. So area of all orifices. So here in this question only one orifice is considered, so here n is equal to 1. So how to calculate area? Pi by 4 d square multiplied by n, where n is the number of orifices. But for this question we will consider n is equal to 1. Now injection velocity, so we have calculated the duration of the injection, that is injection velocity we have calculated earlier, that is Vf, so we will take as it is. Now time of one injection or duration of the injection we have calculated for this question. It is calculated by theta divided by 362 into n by 60. So we will put all this information. So value of Q is known, so we will put this. Then area of all orifices pi by 4 d square, injection velocity calculated, time of injection or duration of injection calculated. So it is easy for us to calculate this diameter d. Now we will take this area of orifice pi by 4 d square is equal to this Q, that is the volume of fuel injected, divided by injection velocity multiplied by time of injection. So these two parameters we have calculated earlier. Now if we observe, this unit of Q is meter cube per cylinder. So I will write here meter cube per cylinder. Then injection velocity, it is meter per second. And time of injection, so it is calculated in terms of second. So its the unit was second. So if we observe, this second is getting cancelled, then this meter cube and this meter is getting cancelled, so remaining is meter square. But if we observe the left hand side, pi by 4 d square, so for the d square it is meter square. So when we take this square root on both sides, then for the d it will become meter. So for d it is 0.79 into 10 raised to minus 3 meter. So we can say that answer is 0.79 millimeter.